All right, so we've talked very generally about how if a function describes some quantity, then the derivative of the function describes the rate of change of that quantity. And moreover, if the derivative is positive, we know whatever it is increasing, the derivative is negative, whatever it is decreasing, and if the derivative is zero, whatever it is constant. And that's just like slope, right? Everything in calculus is slope. If you have a positive slope, that's an increasing function, negative slope is a decreasing function, and a zero slope is constant function. All right, so now what we're going to do is look at the specific case where you have a function, I'm going to call it x of t, but by the way, it could equally well be y of t, and it's going to represent the position of an object. So we could do y of t, we prefer to use y of t if we are talking about the height of some object that's moving, and x of t if we're talking about the left-right position of something that's moving. All right, so pretty basic stuff. All right, so then x prime of t, you know, what is it? It's the instantaneous rate of change of position. All right, well, that is exactly what we mean by velocity. So if x of t is a function giving the position, x prime of t is a function giving the velocity. So that connects back, by the way, to, you know, the first thing you ever learned about distance, rate, and time is distance equals rate times time. All right, because distance equals rate times time, it follows that rate is distance divided by time, or really distance equals rate times time because distance divided by time is what we mean by rate. All right, and then we can sort of broaden this out and say distance means a change in position, right? What does distance mean? It's a change in position. And then by time, we really mean an interval of time, so it means a change in time. So it's really like an x2 minus x1 or x final minus x initial, right? X final minus x zero, sometimes they say in physics, and then t minus t zero, right? So this is really, again, a slope function, x2 minus x1 over t2 minus t1, all right? But these are what we mean by average velocity, all right? And then, but the instantaneous velocity is the limit as delta t approaches zero of delta x over delta t, which we write as dx dt, or if it were y, it would be dy dt, or x prime of t, and that is the instantaneous velocity at time t, right? So it's a function that depends on t, and it's telling you different velocities at different times, okay? So armed with this idea, right, that v of t is equal to x prime of t, all right? Or if we have something that's vertical, v of t is equal to y prime of t, right? This is something moving horizontally. This is something moving vertically, right? Suppose we come back all the way back to the beginning and look at our robotic Mars probe that gave us a function y of t that gave the height of the probe for any time t. Right? So here's, if we knew calculus then, we could have said, well, look, y of t equals 120,000 minus 1.17 t cubed, all right? That's the given function. And so if I know that velocity is the derivative of position, and I also know the power rule, right? Then I know that the derivative of 120,000, derivative constant is zero. This derivative, I'm going to have negative. I'm going to go 3 times 1.17, which is 3.51 t squared. And that's it. That's the derivative. Then, like our whole motivation for this 4-page packet, right, that we did all these charts and tables and all kinds of things, was that we wanted to know the vehicle's speed at t equals 25. All right, what calculus allows you to do is say that the speed at 25 is negative 3.51 times 25 squared. Throw that into your calculator and you get negative 2187.5 meters per second, because this was meters. And that's it. That's your 4-page document in 3 lines. All right. So what this means is this is the vertical velocity at t equals 25. We know that this object is moving downward because y prime of 25 is less than 0. In particular, we know it's moving downward at t equals 25. And we hope it's moving downward for the whole domain of the landing approach, but it might not. It might be something that sort of goes up and down. The Curiosity thing did a hovercraft thing, and maybe it went up sometimes. Anyway, that's all. These right here could replace this entire packet. That is the power of calculus and the derivative. All right. Now, so why didn't you just tell me that in the first place, is what people always say. Because you have to know where it came from and what it means and what it's all about. All right, so, but we can do more, all right? Because if x prime of t is the instantaneous rate of change, and that's velocity, and we call that v of t, it's a new function, v of t, then I could do the derivative of that new function. If v of t is velocity, then v prime of t is the instantaneous rate of change of velocity. Well, that is what we know as acceleration. So if you haven't had physics, you might not know that what acceleration means is the instantaneous rate of change of velocity. If you have had physics, you know that, all right? And we usually represent that with a of t for acceleration at time t. All right, so then we can say that the acceleration at time t is equal to v prime of t, and since v prime is equal to the derivative of, since v is the derivative of x, this is really x prime of t prime. In other words, I take the derivative of x and then take the derivative of that. So we call this x double prime of t. All right, so this is called a second derivative. And we're going to say a lot more about stuff like that. A second derivative, all right, x double prime of t. So here's sort of a summary that we can make about position and velocity and acceleration. If x of t equals position, then x prime of t equals v of t is velocity, and x double prime of t is equal to acceleration is equal to, well, all right, I'm repeating myself, but that's what I do, acceleration, all right? And so you can also say that this is equal to v prime of t. All right, so there's a relationship between position, velocity, and acceleration. We can say a great deal more about that in our next video.